Transformation of graphs. In order to transform any graph successfully, you need to know what the parent function looks like. Our first example is an absolute value function. So the parent function would be y equals the absolute value of x. Now, the look of a parent function is something that you will just have to memorize. I will go ahead and draw a parent function to help us with a transformation. This is a parent function of y equals the absolute value of x. It looks like a V. On the right, the line has a slope of 1. On the left, the line has a slope of -1. Now let's go ahead and describe the transformation that's happening with our function h of x. So we have, I'm going to go ahead and rewrite it so that I can point out some stuff. So this is x. I'm going to break up that plus sign into x minus and then -1 and then -4. So we have a couple of things that are happening here. So this -1 right here, this means that the function has been shifted or translated 1 unit to the left. The translate and shift are used interchangeably. Now this right here means that the function has been shifted or translated 4 units down. So that's all that's happening with this function. Nothing else is different. So let's go ahead and do the actual transformation. In order to do this successfully, we have to have a couple of points that we are focused on. So I'm going to just grab the 3 points on the original parent function, and we're going to translate those 3 points. So this point, it's called the vertex, we'll go ahead and move it 1 to the left and 4 down. 1 to the left and 1, 2, 3, 4 down. So that is our new vertex. Then this point is going to be moved 1 to the left and 4 down. 1, 1, 2, 3, 4. That's the other point. And then this one, the same thing. 1 to the left, 1, 2, 3, 4 down. And then you just connect the dots, making sure that the shape matches the shape of the parent function. Go ahead and erase the counting squares. And that is the graph of the translated function h of x. Let's try it again, but with a different function. So this time h of x is -3, then still the absolute value of x minus 4 plus 6. So the parent function is still the same as what we had before. So I'll go ahead and sketch a quick graph. It's a little off, but that's okay. We'll be working with this point, and this point. So we'll go ahead and describe the transformation of this function first. And I'll try to point out everything that's happening here. So this function, we'll start with a negative sign. It's reflected. And then it's got a 3 in front of the absolute value bars. It's also been stretched by a factor of 3. This is a vertical stretch. Now, the -4, or what looks like a -4, inside of the absolute value bars, you have to be careful with that one. I said -4, it's not true. This negative sign goes with the x, so actually that is just a 4, it's a +4. So the function has been translated. Four units to the right. And then the +6 on the outside. 6 units up. All right, let's go ahead and put it together on a graph. I like starting with translations so that I don't get lost along the way. So we're going to shift 4 units to the right and 6 units up. We're going to start with the vertex. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. This is your vertex. That is your starting point. So the function has been reflected, so it's going to be upside down. And it has been stretched vertically by 3. What does that mean? That means that the distance between this point and this point, just the first point off the vertex, it doesn't work as well for all the other points. But the first point off the vertex, instead of the distance between those 2 points being 1, it's going to be 3. So it's sort of equivalent to a slope of 3. 1, 2, 3, and 1 down. Why am I going down and not up? Because the function was reflected vertically. So it's going to point down and not up. There we go. Let's try a different function. So this time it's a quadratic. So parent function is x squared. We'll go ahead and graph it so that we know what it looks like. You do need to memorize what parent functions look like in order to be effective in this technique. So this is a parent function of y equals x squared. What's happening to our function? So let's break it down. H at x equals 3, x minus 2 squared minus 6. Now this 3 right here, that is a vertical stretch by 3. Now the 2 inside with the x. So the negative sign belongs to the x, does not belong to 2. So that 2, it's a horizontal translation by 2. Two to the right. And then the negative 6. Do a different color here. This negative 6, that is a vertical translation, and it goes down 6. Okay, now putting it all together in the actual graph. I like starting with translations first. So we're going 2 to the right and 6 down. We're going to start with the vertex. 2 to the right, that's right here. 6 down, that's right here. Okay, the function is still going to open up, point up. It is going to be stretched by 3. So that means that, again, the distance here is 1. Our distance is going to be 3. So 1, 2, 3 up and 1 over. And the same thing on the other side. And that is a sketch of the translated function. One more. So this last one, it's a cubic function. So y equals x cubed. We'll go ahead and get this one plotted. Okay, this is what a parent function looks like. Now for our function, negative, and then x minus 1 cubed plus 3. So this negative means a reflection. vertically. Then the 1 next to the X, this one, that is shift to the right. It's a positive 1. And the plus 3 on the outside of the parenthesis, that means shift. Shift and translate is the same thing. Well, not to, shift up 3 units. Let's go ahead and do the actual graph. Start with the translations or shifts to the right 1 and up 3. That's right here. Now the function has not been stretched, but it has been reflected. What does that mean? Well, the original function, the left end points down and the right end points up. In the reflected function, the left end will point up and the right end will point down. So something like that.